Since the dawn of humanity, we have gazed up at the vast expanse of the cosmos, filled with awe and wonder. The twinkling stars, the ethereal glow of distant galaxies, all whisper of mysteries that have captivated our imaginations for millennia. But perhaps the greatest enigma of all lies in the very origin of the universe itself, a question that has puzzled philosophers and scientists for centuries. How did this grand cosmic tapestry with its intricate web of stars, galaxies, and planets come into being? For much of human history, the answer to this profound question was shrouded in mythology and religious beliefs. Ancient civilizations wove intricate tales of gods and goddesses who breathed life into the universe, while others envisioned a cosmic egg from which all of creation emerged. These narratives provided a sense of comfort and meaning in a world that often felt chaotic and unpredictable. However, with the advent of modern science, our understanding of the universe has undergone a profound transformation. The prevailing scientific theory for the origin of the universe is the Big Bang model, which posits that the cosmos began from an extremely hot, dense state approximately 13.8 billion years ago. According to this theory, space and time themselves were born in this cataclysmic event, and the universe has been expanding and cooling ever since. The Big Bang model is supported by a wealth of observational evidence, including the cosmic microwave background radiation, a faint afterglow of the Big Bang itself. However, despite its successes, the Big Bang theory does not answer all of our questions about the universe's origin. It leaves us with tantalizing hints of a deeper reality, prompting us to explore even more profound questions. What existed before the Big Bang? What caused this cosmic explosion in the first place? These are the ultimate enigmas that continue to drive our quest to unravel the mysteries of the cosmos. To comprehend the enigma of the universe's origin, we must first grasp our current understanding of its evolution. The Big Bang model provides a compelling framework for understanding the universe's history, tracing its expansion and cooling from an incredibly hot, dense state to its present form. As the universe expanded, it cooled, allowing for the formation of particles, atoms, stars, and eventually, galaxies. This cosmic evolution is not a static process, but rather a dynamic interplay of forces and phenomena. Gravity sculpted vast cosmic structures, drawing matter together to form galaxies and clusters of galaxies. Within these galaxies, stars were born, lived out their life cycles, and in some cases, exploded as supernovae, scattering the building blocks of life across the cosmos. The very elements that make up our bodies, the air we breathe, and the ground beneath our feet, were forged in the nuclear furnaces of stars. We are, in a very real sense, children of the cosmos, our existence intricately intertwined with the universe's grand evolutionary narrative. Yet, the Big Bang theory, while illuminating the universe's history, leaves us at the precipice of a profound mystery, the very beginning itself. What existed before the Big Bang? This question takes us to the very edge of our scientific understanding, into the realm of speculation and conjecture. However, this lack of definitive answers has not deterred physicists and cosmologists from exploring intriguing possibilities, seeking to peer beyond the veil of the Big Bang and unravel the universe's ultimate origin. One intriguing possibility is that our universe is not the first, nor will it be the last, but rather part of an eternal cycle of cosmic expansion and contraction. This idea, known as the cyclic universe model, suggests that the Big Bang was not the beginning of time, but rather a transition point in an infinite series of Big Bangs and Big Crunches. In this scenario, our universe expands for eons, eventually reaching a point where the expansion slows down and reverses, leading to a contraction phase. As the universe contracts, galaxies draw closer together, eventually colliding and merging. Temperatures soar as the universe collapses in on itself, ultimately reaching a state of immense density and heat, a Big Crunch. This singularity then becomes the seed for the next Big Bang, igniting a new cycle of cosmic expansion. The cyclic universe model offers an elegant solution to the problem of the Big Bang's singularity, suggesting that the universe is not bound by a single beginning or end, but rather exists in a perpetual state of renewal. However, the cyclic universe model faces its own set of challenges. One of the key questions is what mechanism drives the transition from a contracting universe to an expanding one. Some proponents of the cyclic model suggest that dark energy, a mysterious force that is currently accelerating the expansion of our universe, may play a role in this cosmic turnaround. Another challenge lies in explaining how information from the previous universe survives the Big Crunch and is imprinted on the next cycle. Despite these challenges, the cyclic universe model remains an intriguing possibility, offering a tantalizing glimpse into a cosmos that is eternal and ever-evolving. Another captivating idea that has emerged from the quest to understand the universe's origin is the concept of the multiverse, a hypothetical realm where our universe is just one of countless others, each with its own unique set of physical laws and constants. The multiverse concept arises from various theoretical frameworks, including string theory and inflationary cosmology, which suggests that our universe may be a single bubble in a vast cosmic foam of universes. In this grand cosmic tapestry, each universe represents a different realization of the laws of physics, with some universes being hospitable to life, while others remain barren and lifeless. The multiverse concept, while still highly speculative, offers a mind-boggling perspective on the nature of reality, suggesting that our universe, with its intricate web of stars, galaxies, and life, may be just one tiny pocket in an infinite expanse of cosmic possibilities. One of the most intriguing aspects of the multiverse concept is the possibility that these other universes may not be entirely separate from our own, but could interact with each other in subtle ways. Some theories suggest that collisions between bubble universes could leave observable imprints on the cosmic microwave background radiation, providing a potential avenue for testing the multiverse hypothesis. However, the vastness and inaccessibility of the multiverse present significant challenges for observational verification. Despite these challenges, the multiverse concept remains a tantalizing possibility, offering a glimpse into a realm of cosmic wonders that stretch the very limits of our imagination. Imagine a universe that is the mirror image of our own, where time runs backward, matter is replaced by antimatter, and left and right are reversed. This intriguing concept, known as the anti-universe, has captured the imagination of physicists and science fiction writers alike. The idea stems from the fundamental symmetries observed in the laws of physics, which suggest that for every particle, there exists an antiparticle with opposite charge. The anti-universe hypothesis proposes that during the Big Bang, equal amounts of matter and antimatter were created. And while our universe evolved with a predominance of matter, a mirror universe emerged with a predominance of antimatter. In this mirror universe, time would run backward relative to our perspective, and the arrow of time, which points from the past to the future in our universe, would point in the opposite direction. While the concept of an anti-universe is highly speculative, it raises profound questions about the nature of time, symmetry, and the fundamental building blocks of the cosmos. Could there be a realm where time flows in reverse, and our antimatter counterparts live out their lives in a universe that is both familiar and profoundly alien? However, detecting and studying such an anti-universe presents formidable challenges. If it exists, it would likely be located far beyond our observable universe, making direct observation impossible. Nevertheless, the anti-universe concept remains an intriguing possibility, a testament to the boundless creativity of the human mind in its quest to unravel the universe's mysteries. The quest to understand the universe's origin is akin to piecing together a vast, intricate puzzle. We have made remarkable progress, uncovering clues about the universe's evolution and developing sophisticated theories to explain its behavior. The Big Bang model, with its supporting evidence from the cosmic microwave background radiation and the abundance of light elements, provides a compelling framework for understanding the universe's history. However, the very beginning, the moment of the Big Bang itself, remains shrouded in mystery. Our current theories break down at this point, unable to describe the extreme conditions of density and temperature that prevailed in the universe's infancy. To penetrate this cosmic enigma, we need to push the boundaries of our knowledge, exploring new theoretical frameworks, and developing innovative observational techniques. The search for the universe's origin is not merely an academic pursuit, it is a testament to our innate curiosity, our drive to comprehend the cosmos and our place within it. The universe holds countless secrets, and each discovery brings us closer to understanding our cosmic origins and the intricate web of connections that make up the fabric of reality. The universe is often compared to a grand symphony, with its intricate interplay of forces and phenomena creating a harmonious balance that has allowed for the emergence of stars, galaxies, and life. From the smallest subatomic particles to the largest cosmic structures, the universe operates according to a set of fundamental laws that govern its behavior. These laws, encoded in the fabric of space-time, dictate the interactions between matter and energy, shaping the universe's evolution from the Big Bang to the present day. Gravity, the weakest of the fundamental forces, plays a dominant role in sculpting the universe's large-scale structure, drawing matter together to form galaxies and clusters of galaxies. Electromagnetism, responsible for the interactions between charged particles, governs the behavior of atoms and molecules, forming the basis for chemistry and life itself. The strong and weak nuclear forces operate within the hearts of atoms, binding protons and neutrons together and governing the processes of nuclear fusion and radioactive decay. These four fundamental forces, acting in concert, create the cosmic symphony that we observe, a delicate balance of order and chaos that has allowed for the emergence of complexity and life in our universe. Understanding these forces and their interplay is crucial to unraveling the mysteries of the universe's origin and its ultimate fate. In the realm of quantum mechanics, the study of the very small, the universe is a turbulent sea of quantum fluctuations, where particles can pop in and out of existence, defying our classical intuitions about reality. These fluctuations, inherent to the quantum vacuum, are thought to have played a crucial role in the very early universe, potentially providing the seeds for the large-scale structure we observe today. According to inflationary cosmology, a brief period of exponential expansion in the universe's first fraction of a second, these quantum fluctuations were stretched out to cosmological scales, creating tiny variations in the density of the early universe. These density variations, amplified by gravity over billions of years, are thought to have given rise to the cosmic web of galaxies and voids that we observe today. The concept of quantum fluctuations as seeds of cosmic structure is a testament to the interconnectedness of the very small and the very large, highlighting the profound implications of quantum mechanics for our understanding of the universe on a cosmic scale. This interplay between the quantum realm and the vast expanse of the cosmos is a frontier of scientific inquiry, offering tantalizing glimpses into the fundamental nature of reality. The search for the universe's origin is a quest for evidence, for clues that can shed light on the universe's earliest moments. Scientists are constantly pushing the boundaries of observation, developing new telescopes and detectors capable of probing deeper into the cosmos and capturing faint echoes of the Big Bang itself. The cosmic microwave background radiation, a faint afterglow of the Big Bang, provides a snapshot of the universe as it was just 380,000 years after the Big Bang. By studying the subtle temperature variations in this radiation, scientists can glean insights into the universe's early conditions, its geometry, and its composition. Another avenue of exploration involves studying the oldest stars in the universe, which formed shortly after the Big Bang. These stellar fossils contain information about the chemical composition of the early universe, providing clues about the processes of star formation and the evolution of galaxies. The quest for evidence is a collaborative endeavor, involving scientists from around the globe working together to unlock the universe's secrets. Each new observation, each theoretical breakthrough, brings us closer to understanding our cosmic origins and the intricate web of connections that make up the fabric of reality. The search for the universe's origin is not merely an academic pursuit. It has profound implications for our understanding of ourselves and our place in the cosmos. By unraveling the mysteries of the universe's beginnings, we gain a deeper appreciation for the vastness of time and space, the interconnectedness of all things, and the preciousness of life itself. The realization that we are stardust, that the very atoms in our bodies were forged in the hearts of stars billions of years ago, fosters a sense of awe and wonder at the grandeur of the cosmos. It reminds us that we are part of something much larger than ourselves, a grand cosmic narrative that stretches back to the dawn of time. Furthermore, The study of the universe's origin challenges our preconceived notions about the nature of reality, pushing the boundaries of human knowledge and inspiring future generations to explore the cosmos with curiosity and imagination. The pursuit of cosmic knowledge is a testament to the human spirit, our innate desire to comprehend the universe and our place within it. The cosmos, with its vast expanse and countless mysteries, has always held an enduring allure for humanity. From ancient civilizations charting the stars to modern astronomers peering deep into the universe with powerful telescopes, we have always been drawn to the unknown, compelled to explore the cosmos and unravel its secrets. The search for the universe's origin is perhaps the ultimate expression of this human curiosity, a quest to understand our cosmic roots and the fundamental nature of reality itself. The universe is our ultimate frontier, a vast and uncharted territory ripe for exploration and discovery. Each new observation, each theoretical breakthrough, brings us closer to understanding our place in the grand cosmic tapestry. The cosmos is a source of endless wonder, inspiring awe and humility in equal measure. As we stand on the precipice of the unknown, peering into the depths of the cosmos, we are reminded of the vastness of our ignorance. The universe is a humbling place, revealing the limitations of our current understanding and challenging us to push the boundaries of human knowledge. The search for the universe's origin is a journey into uncharted territories of knowledge, a quest that will likely continue for generations to come. Each new discovery raises more questions than it answers, revealing new layers of complexity and wonder in the cosmic tapestry. The pursuit of cosmic knowledge is not for the faint of heart. It requires patience, perseverance, and a willingness to embrace uncertainty. But the rewards are immeasurable, offering profound insights into the nature of reality and our place within it.